Today we are going to conduct the block rotor test on 3-phase squirrel cage induction motor. Objectives for today's experiment is to find the variable losses present in the 3-phase induction motor and also to determine the series branch parameters in the equivalent circuit diagram of 3-phase squirrel cage induction motor. Series branch parameters are stator winding resistance, stator winding reactance, rotor winding resistance and rotor winding leakage reactance. Last time we have used this circuit diagram for no load test. Same circuit we are also going to use for block rotor test. Last time we have used this same motor for no load test on 3-phase squirrel cage induction motor. Today we are using same motor for block rotor test. Last time we haven't applied any spring balanced weight on this rotor. Today we have applied spring balanced weights on this rotor so that this rotor should be blocked. If you observe this, it is blocked. If you observe this 3-phase 415 volts 50 Hz AC supply is given to the 3-phase auto transformer input terminals, and output terminals R is connected to the one wire is connected to the voltmeter and another wire is connected to the ammeter. Ammeter second terminal is connected to the short circuit point of U1 and W2, and here B wire, output of 3-phase B wire is connected to the one wire is connected to the voltmeter second terminal and another wire is connected to the interconnection of V1 and U2 terminal, and output terminal of 3-phase auto transformer Y is connected to the interconnection of V2 and W1 point. In this experiment also we are not using the voltmeter and ammeter wattmeters. In place of voltmeter, ammeter and wattmeters, we are using the digital power analyzer to measure the line voltage, line current and power consumed by the 3-phase induction motor. This is the main supply, 3-phase supply. This supply is given to the 3-phase auto transformer input, and output terminals we have connected to the 3-phase induction motor. Here the stator windings are connected in delta, that is U1, W2 are joined and V2, W1 are joined. Here U2 and V1 are joined. Now auto transformer R wire is connected to the junction of U1 and W2. Y wire is connected to the junction of V2 and W1, and blue wire B wire is connected to the junction of U2 and V1. By using digital power analyzer, we are going to measure the line current, line voltage and power consumed by the 3-phase induction motor. For that we have connected this R wire is connected inside the clamp. This will sense the current, and the digital power analyzer voltage probes, that is a black probe and red color probe, connected across R and B wires. It will measure the line voltage. If we change the power settings here, we will get the W1. If we change the black voltage probe to Y phase and this current clamp to Y phase, then we will measure the W2. I have switched on the 3-phase AC supply, and then I am going to apply the rated current. Rated current of 3-phase induction motor is 7.5 amperes. We have blocked the rotor. Now we are going to apply the rated current by adjusting the 3-phase variac. Now we have applied the rated line current, that is 7.5 amperes. We have applied the 7.5 amperes rated current. At this condition, applied voltage, line voltage is 75 volts. By applying the 75 volts, we have achieved the 7.5 amps of line current. And by changing the settings, we can measure the power consumed by the three-phase induction motor at black rotor condition. Now it is showing 0.5 kilowatt. This is W1. By changing this terminal to Y and this current sensor to Y, we will measure the W2. Here W2 is 0.02 kilowatt. Sum of W1 and W2 will give the power drawn by the three-phase induction motor, that is 0.52 kilowatt. Now I am going to reduce the three-phase variac to 0 volts, and then I am going to switch off the three-phase supply. This is the observation tabular form for black rotor test on three-phase squirrel cage induction motor. First, we kept the current at rated value, that is 7.5 amperes. At that time, we have noted down the voltage across line to line, that is 75 volts. And wattmeter 1 reading is 0.5 kilowatt, wattmeter 2 is 0.02 kilowatt. Power consumed by the three-phase induction motor under black rotor condition will give the W1 plus W2, that is equal to 0.52 kilowatt. We have taken this VBR, IBR and PBR readings from the black rotor test experiment. From these values, we have determined the power factor at black rotor condition, power factor angle at black rotor condition, then impedance at black rotor condition. From the impedance, we will get R suffix BR plus X suffix BR values from the impedance. From x1 is equal to x2 dash is equal to x suffix br by 2. From this we will find the stator leakage reactance and rotor winding leakage reactance, that is equal to 7.3236 ohms per phase. And from this equation, RBR is equal to R1 plus R2 dash, that is equal to 9.2444 ohms per phase. And we know R1 value we have measured by using the DC ammeter and voltmeter method. Here we measured R1 is equal to 4.23 ohms. If we substitute R1 value here, we will get R2 dash value, that is rotor winding resistance under black rotor condition, is equal to 5.0144 ohms per phase. From the no load test, we have taken this V1 rated, that is equal to 415 volts, INL is equal to 4.07 amps, P suffix NL is equal to 340 watts. By using these experimental data, we have determined the power factor at no load condition, that is equal to cos of theta suffix NL, that is equal to 0.1162 lagging. And from this we have determined the power factor phase angle, that is equal to 83.3261 degrees. Then we have determined the magnetizing component of current and core loss component of current. These are per phase currents only. From this equation, we have determined the stator induced EMF volts per phase. By using this equation, magnetizing component of reactance is equal to E1 by I suffix m. If we substitute these values, we will get a magnetizing component reactance is equal to 176.84 ohms per phase, and core loss component of resistance is equal to E1 by IC, that is equal to 1511.31 ohms per phase. And this is the, after knowing this magnetizing equivalent circuit parameters, we can draw the per phase equivalent circuit diagram of 3-phase squirrel cage induction motor. Here this is R1, this is X1, stator winding leakage reactance, and here it is stator winding rotor winding leakage reactance, and here it is R2 dash by S, where S is the slip, and here R2 dash we have substituted 5.0144 ohms, and this rotor winding resistance can be represented by R2 dash by S. When the rotor is blocked, S is equal to 1, that time it will be R2 dash only. From the above experimental data, we can also determine the constant losses, that is sum of iron plus friction and windage losses, that is equal to 338.17 watts, and variable losses is equal to 520 watts.